Hello and welcome to another exciting maths class, and today we're going to be discovering different methods that we can use when we're trying to find an area between our graph and the x-axis. So let's get into it. Now, many things that we need to be aware of. First of all, integrating finds the area under the curve. So far, we found approximate areas under the curve. We used the trapezoidal rule, we used Simpson's rule, and that found approximate areas. But now we're going to find the exact areas. But it gets a bit tricky, because if the area is below the x-axis, the answer ends up with a negative sign. So effectively what happens is this. If we have a graph, and I draw it, and let's say I want to find the integral between 1 and 4, that's the area that we will find. And you get an answer. But if, when I draw my graph, let's say it was an upside down parabola, and I went between 1 and 4, the area now is under the x-axis, which means when we actually use our special formulas, we get a negative answer. What happens is, for any part of the graph that's above the x-axis, we get a positive answer. Any part of the graph that's below the x-axis, we end up with a negative answer. So let's actually do some examples to try and see that. But in order to compensate for the negative sign, we put these absolute value signs there, because what that does is it says, hey, I don't care if you're positive or negative. Let's just give you the answer as a positive number. Always draw a sketch when you can, because it'll make it a whole lot easier to see where an area is above or below the x-axis. So let's look at our first example. We have to find the area between the curve y equals x squared take 4, which is a parabola pushed down 4 units. So between that curve, the x-axis, and x equals 0 and x equals 2. Well, first thing we need to be aware of is, where does our curve touch the x-axis? So our curve is y equals x squared take 4. To find x-intercepts, we let y equal 0. So ultimately we end up with this. Y is equal to x squared take 4, let y be 0. Plus 4 to both sides, you get x squared equals 4, so x is going to equal positive or negative 2. So this graph touches the x-axis in 2 spots. Let's draw it. Now, if you let x equals 0, you get y equals minus 4, so we can see that down there, and we know it's just a parabola that opens upwards. We want to find the area between the curve, so we've drawn our curve, the x-axis, and between x equals 0 and 2. Well, there's 0, there's 2, so that means we're actually trying to find in here. So let's shade that in. That's the area we're trying to find, that shaded area. We notice that shaded area is under the x-axis. That's okay, we can still find the area. There's our formula for area. We know the area is the absolute value of the integral from 0 to 2, because they're the x values, the extreme left and extreme right x values. So there's my 0 and my 2. X squared take 4, because that's the curve. You always have a dx on the end. Don't worry about the dot. That just, sometimes you can put it there if you wish. But there's our formula. So we need to integrate that. Now, integrating x squared, you look at the x squared, you add 1 to the power and divide by the new power. So x squared will become x cubed over 3, and integrating minus 4 will give you minus x. Now, just like when we were doing definite integrals, we have our numbers on our integral sign, our terminal numbers, so we put them on the right-hand side after we've integrated. Now, wherever we see an x, we're going to plug in 2. Then, wherever we see an x, we're going to plug in 0, and we're going to subtract those two answers. So there we go. X becomes 2, so 2 cubed over 3, minus 4 lots of 2, so that's putting in 2, minus, now we put in a 0 wherever we see x, and you'll get 0 cubed over 3 minus 4 lots of 0. The trick is to put that into your calculator and see what answer you end up with. And when you do that, you end up with minus 16 over 3 or minus 5 1/3. But the absolute value signs basically say, ignore the minus, the area is 5 1/3 units squared. Why did we get a minus answer? Because the area is under the x-axis. If the area was above the x-axis, we would have got a positive answer. So there's our first example. Did you need to draw the sketch to do this? With this particular question, no. You could have got away with just using the formula and plugging it in, but that doesn't always work that way. Alright, here's our second example. Let's find the area between y equals x cubed, the x-axis, and x equals minus 2 and 4. Now we know y equals x cubed, we've graphed that in year 10, it looks something like this. Going through 0, 0. So something like that. Well, y equals x cubed goes through 0, 0, so let's draw a sketch of it. And I want to go between minus 2 and plus 4, so I've shaded that in. Now what you're going to notice is that if you come over here to minus 2, that's when you actually go from minus 2 to the graph, it's below the x-axis. When you go from x equals 4 up to the graph, it's above the x-axis. So between the x-axis and these points and the curve, I have a little bit of shaded area that's below, and a little bit of the shell. Most of the shaded area is above the x-axis. So below the x-axis, above the x-axis. I have to do these two parts separately because this part gives a negative answer, this part gives a positive answer, and if I don't do them separately, that answer will be negative and it will affect this bit here, and you'll get the wrong value for your final answer. I need to look at this part separately. Even though it's negative, I ignore the minus sign and add it to this part. So let's go through the process. We know we're going to go from minus 2 through to 0, and then from 0 through to 4. So let's look at this. The area is going to equal from minus 2 through to 0 of x cubed, dx, plus, then we're going to go from 0 through to 4 of x cubed dx. Now if I wanted to, I could have put absolute value signs around this one as well. Why didn't I? Because when I looked at the graph, I could see that between minus 2 and 2 is when the shaded area is below the x-axis on the graph. So I've got absolute value signs there. And between 0 and 4, it's above the x-axis, so I know I'm going to get a positive answer when I'm above the x-axis, so I haven't bothered with them. But if you wanted to put them there, you could. Now when you integrate x cubed, it just becomes x to the power of 4 over 4, because you add 1 to the power and divide by the new power. So we end up with this. For the first part, it becomes x to the power of 4 over 4, and we put our numbers, minus 2 and 0 there, plus x to the power of 4 over 4, and we put our 0 and our 4 there. Notice I still have the absolute value signs there. So in this first section, everywhere I see an x, I'm going to put 0. Everywhere I see an x, I'm going to put minus 2, and I'm going to subtract the answers. And similarly over here, I'll put in x equals 4 and x equals 0 and subtract those answers. So let's see what we generate. Putting in 0 first, you get 0 to the power of 4 over 4. Minus 2 to the power of 4 over 4. Notice I put brackets there. That's important because that minus 2, when you raise it to the power of 4, is going to become positive. Plus, then we do the other parts. 4 to the power of 4 over 4 minus 0 to the power of 4 over 4. Plug that into your calculator and you get negative 4 from this part, and there's still absolute value signs there, plus 64 from this part. Now the absolute value of minus 4 is plus 4, so it's really 4 plus 64, which is 68. If you hadn't done it as two separate parts, it would have gone minus 64 plus 64 is 60, and you would have got the answer of 60, which is wrong. The answer is 68 units squared for the area between the curve, the x-axis, and x equals minus 2 and x equals 4. Be careful, drawing a sketch shows you the two different parts. Let's try example number 3. Let's find the area between the curve y equals x squared, that's our basic parabola, the x-axis, and x equals -3 and +3. Well, there's our basic parabola, and between -3 and +3, I can see the shaded area between the parabola and the x-axis. Now everything's above the x-axis, so I can do this as the integral from -3 through to 3. But this is symmetrical. So I'm actually going to do something that's a little bit different. I'm going to say, for this question here, I'm going to actually only integrate and find this area here, and I'm going to double it because the area on this side and the area on the negative side are both the same symmetrically. So I'm just going to find the area on the right and double it. So I'm going to go from 0 to 3, and that's what I've got written here. 2 lots of the integral from 0 through to 3 of the x squared graph with respect to x. Now when you integrate x squared, add 1 to the power, divide by the new power, you get x cubed over 3. That 2 will stay out the front of the square bracket. So we end up with 2 lots of x cubed over 3 with my numbers 3 and 0. Remember, as I said before, I could have had -3 there and 3 there, then I wouldn't have the 2 out the front. But it's really easy to substitute 0, makes it a bit quicker. So I get 2 lots of, put in 3 first, you get 3 cubed over 3 minus 0 cubed over 3. Now 0 cubed over 3 just becomes 0, so that's easy. You do 2 lots of 3 cubed over 3, you end up with an answer of 2 lots of 9, which is 18 units squared. You can see there's 2 lots of 9. The area on this side is 9 units squared and the area on that side is 9 units squared. Drawing the diagram just gave me another option to do that. Well, time for you to do some questions. Enjoy!